section 1.5, problem number 3, we're adding two fractions together. Whenever we're adding fractions together, we always want to look at the denominators and see if they're the same. Here we have a 5 and a 4, so they are not the same. So we need to change them into having a common denominator. We always do that by multiplying by the denominator of the other fraction. So here, if 2 over 5, we need to multiply by the denominator of the other one. So we multiply this first fraction by 4 over 4. We need the 4 in the denominator to get the common denominator, but we're not allowed to change its value, so we have to multiply the numerator by 4 as well. For the second fraction, we do a similar thing. We need to look at the denominator we had before, which was 5, and we multiply this by 5 over 5. Same thing, we needed a 5 in the denominator so that we'll have a common denominator, and then we need to multiply 5 in the numerator as well so we don't change its value. Now we need to go through and do each of these multiplications independently. So when we multiply fractions, we just multiply across. We have 4 times 2 is 8, and 4 times 5 is 20. And to that we add these two multiplied together. So on the top here we have 3 times 5, which is 15, and 4 times 5, which is 20. So now we've changed those two original fractions into fractions that have a common denominator. When they have a common denominator, we can just add the top and keep the bottom. So we have 8 plus 15 over 20. And we can simplify 8 over 15 to 23 over 20. Lastly, we always need to see if these can be reduced. 23 is a prime number. It cannot be reduced. 20 can be prime factored. So we end up with 20's prime factorization is 2 times 2 times 5. None of these numbers match, so this cannot be reduced. This is its simplest form. So when we add these two fractions together, we end up with 23 over 20.